Hello everyone. On this video we will be looking at our piecewise limits. Okay, now the one thing you have to remember is that not every function has a limit that exists. Okay, so in other videos, you may see us just plug in the value and it gives us our limit, or we use the table and the table directs us towards the limit. We just have to remember that there won't always be a limit. Okay, how do we know that? Well, the second thing you want to remember is that limits only exist if they are the same when approaching a constant that we call C from the left and right. Okay, so that means, let's say if the limit is 3 when you approach it from the left, if your limit is 4 when you approach it from the right, then it's not, then there's no limit. Okay, limit doesn't exist. Okay, so let me give you a quick example. Let's say the limit of the absolute value of x over x as x approaches 0. And kind of separate that. Okay. So we know that when x is approaching 0, we get our number line. That's our 0. So we know x is approaching 0 from the left. And this way, put a little arrow up here. And from this way, x is approaching 0 from the right. Okay, so we didn't put our graph up here because I want you to be able to kind of figure it out without always looking at a graph. Okay, so if we have this value here, let's say we look at x approaching 0 from the right. Okay, so when x is greater than 0, or approach from the right, we have to see that all of our values are positive. Okay, of course that means that if you have anything to the right of 0, you have 1, 2, 3, even 0.1 or 0.5, whatever it is, they're all positive to the right of 0. Okay, so what does that mean? That means that all of your x values to the right are positive. So this is how we're going to approach this one. Let me move that up a little. Yeah, the limit, absolute value of x over x, x approaches 0, but this time we're just coming from the right. And we'll have certain ways to denote that, and I'll show you that in a second, but right now we're just kind of looking at it from the right. Okay, so if every value of x is positive, what do you have? You have the absolute value of a positive number, which is just that positive number all over that positive number. Okay, so that means coming from the right, your limit is 1. Alright, so let's move up a little bit and now look at when you're approaching from the left. When x is less than 0, of course you're going to approach 0 from the left. Okay, so when you're approaching 0 from the left, of course, everything to the left of 0 is going to be negative. Okay, everything from -1, -2, blah, 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 all the way down. So everything to the left of 0 is negative. All values are negative. Okay, so how does that look with this one? You have the limit as x approaches 0, and again, we're going to give you the documentation. Oh, we'll wait to denote that one a little later, but we're just coming from the left. All right, so that means we have absolute value of x over x. We have the absolute value of a negative value now. So remember, if it's 1, 2, 3, anything negative number, it's all going to be a negative value all over negative x. Okay, because remember, approaching from the left, everything is negative. Okay, so what does that give you? The absolute value of a negative number is just going to be a positive number. So the absolute value of a negative, let's say -4, would just be 4. So the absolute value of a negative x is just going to be x all over that same negative x, because remember, it's still coming from the left, and that value would be negative. So that means anything divided by its negative self is just -1. Okay, so if it's approaching from the right, the limit is 1. If it's approaching from the left, the limit is -1. Okay, so since these two are not the same, we know the limit does not exist. Okay, and when it doesn't exist, for the most part, you'll just see DNE. Does not exist. Alright, so I'm going to give you kind of a general idea. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our general idea. Alright, let me bring this paper on down. Okay, so in general, the limit of f of x only exists, as x approaches c, forgot that little part, when, and this is the terminology I promised you before, the limit of f of x as x approaches c, put a little minus sign next up, kind of up there. So this means approaches from the left. Here we go. Alright. And that's equal to the limit of f of x as x approaches c. If you put a little plus sign next to it, that means you're approaching from the right. So if you're approaching that c from the left, it has to equal the same as approaching that c from the right. Okay, so just to kind of clear it up, let me separate this just a little bit. But the arrows still are pointing to it. So that, I don't think that yet. C with the little plus sign means approaches from the right. Uh-oh, sorry about that. All right. Okay, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, so let's say, for example, if you wanted to find the limit of f of x as x approaches 2 when, let's say, your f of x is the piecewise function. Let's say it's equal to 1 when x does not equal 2. And let's say that it's 0 when x does equal 2. Okay, so to kind of help you visualize it, we're going to use a graph for this one because our f functions are fairly simple. It's nothing all that complicated. When it's 1 and 0, you're looking at just horizontal lines. Okay, so let me go ahead and make a quick graph. Alright, so we have that right there. So we have our x-axis and our y-axis there. Now let's say this is your f of x equal 1. And so don't want to make that confusing, so I'll just leave that as 1. Okay, so f of x equal 1 is right there. I'm going to bubble in, say x equal 1, x equals 2. Remember that when x is equal to 2, or it's only equal to 1 when x is not equal to. So when it gets to 2, it's kind of an open circle. Okay, so this is your f of x equal 1, or your y equals 1. Okay, so your f of x is equal to 0 when x is equal to 2. So that means that's your x equals 2. It means your y is equal to 0. Okay? So what we're looking at here is that the limit when you're approaching 2 from the left is the same as when you're approaching 2 from the right. Okay? So that means the limit of f of x as x approaches 2 from the left is equal to the limit of f of x as x approaches 2 from the right. Okay, so when they're both the same, that means the limit of f of x as x approaches 2 is equal to 1. So remember, the limit is just how high or how low that value is going to be. So since you're approaching from the left and from the right, that limit is 1. Okay, they're not asking for the actual value. Okay, they're just asking for the limit as you're approaching. That's the key there. Approaching. That one word approaching can be left out sometimes. You don't want to leave that out. Remember, you're just approaching 2. So when you're approaching 2, that value may be completely different than when you actually are on 2. Okay, so when you actually reach 2, it's completely different from approaching 2. Alright? So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so let's say, for example, you want to find the limit x approaches -7 of 5 times x plus 7 over -2 times the absolute value of x plus 7. Alright, so this is how we're going to approach this one. So the first thing we're going to do, just to kind of simplify that a little bit, is we're going to factor out our constant. Okay, so we're going to factor out that -5/2. Remember your properties of limits, you can factor out those constants right out to the front. So that would be -5/2 times the limit as x approaches -7, x plus 7 over absolute value of x plus 7. Alright, so that's all we did, just to kind of simplify that and make it not so scary looking. Okay, now remember here we're approaching -7. So just to put our number line, we have our -7. Okay, now remember with negative numbers, it can get a little confusing, because if you were approaching 7, it will be 6, 6.5, 6.9, and then it will be 8. You'd have 7.5, 7.1, 7.01, and then keep going and going and going. But remember, this is negative. Let's say this would be your -6, and this would be your -8. You want to be aware with negative numbers that directions kind of change when the absolute value increases. Okay, so here you have -6.5, -6.9, -6.99, -6.999, and you go from there. So let's say here x equals -6.99. And let's say here x equals -7.01. Okay, so we're approaching our -7. Okay, we're approaching it from the right and left. So from left approach from the right. And honestly, drawing out a little number line until you're completely used to limits is usually a good idea. Okay, that little extra 4 or 5 seconds to draw out a number line can prevent you from making a little small mistake when you're rushing. So, like I said, drawing just that little number line, you don't have to draw a full page one, you can draw one in the little corner next to the problem, but it really does help you visualize, because sometimes during the pressure of a test, you may sit up there and think, okay, well, approaching from the left is this number, approaching from the right, and you may mix up your negative with your positive. That little extra drawing of the number line can really help. Alright, so now we're going to look at approaching from the left. Okay, so when x is less than -7, or approach from the left, instead of putting in various values leading up to it, we're just going to put in one value that's really, really close, because we already know it's approaching 7. We're just going to put in a value that's really close to -7. Okay, so we know, we'll say x is equal to -7.01. Okay, so what does that give us? That means that, let me rewrite that. Forgot my negative 5 over 2. So negative 5 over 2 times the limit, and we just replace x with negative 7.01. Negative 7.01 plus 7 over the absolute value of negative 7.01 plus 7. Okay, so that's actually as x approaches negative 7. That's actually going to be negative 5 over 2. And since we plugged in the value for x, the limit of a constant is just going to be a constant. So that's going to be negative 0.01 over 0.01. Which anything divided by itself is just going to be that value. And that negative means it's going to be negative 1. So you have negative 5 over 2 times negative 1, which is positive 5 over 2. Alright? So what about when, move this up a little bit, x is greater than negative 7? Approach from the right. Okay, so when we're approaching from the right, instead of going, each individual one, we're just going to go ahead and start at a value really, really close to negative 7 on the right, which is negative 6.99. And x equals negative 6.99. Okay, so just like up here, we're going to go ahead and plug it in. So we have negative 5 over 2 times the limit of negative 6.99 plus 7 over the absolute value of negative 6.99 plus 7 as x approaches negative 7. Alright, so what that gives us is negative 5 over 2 times 0.01 over 0.01. Because these two just end up being the same. So anything divided by itself is just 1. So you have negative 5 over 2 times 1 is negative 5 over 2. Okay. Now we see here, approaching from the left and right will give you two different limits. Okay. So since the limits are not equal from both sides of negative 7, the limit does not exist. Okay, so your answer would just be D and E for does not exist. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Move my paper down. Alright, so let's say, for example, want to find the limit for f of x where f of x is equal to the piecewise function, let's say 2x plus 3 when x is less than 2, and x squared plus 1 when x is greater than or equal to 2. say for problem A, you want to find the, clean that A up a little bit better than that. The limit of f of x as x approaches 1. And let's say for B, the limit of f of x as x approaches 2. Okay, so given that this is our f of x, we want to find the limit of f of x as x approaches 1 and the limit of f of x as x approaches 2. Alright, so again, the best way to approach this would be the use of a number line. Okay, that number line can come in so handy. Okay, so before we start either one, we want to put our number line here. Remember, we're approaching, well, for our f of x, it's on either side of 2. Okay, so this is our x is less than 2, and we're going to include it on this side. We'll just fill in half of that one. And this is our x is greater than or equal to 2. Okay, so this should look kind of like a little half moon. Okay, so we know that whenever x is less than 2, your f of x is equal to 2x plus 3. It tells us that up here. And when your x is greater than or equal to 2, your f of x is equal to x squared plus 1. How do we know? It tells us that up there. Okay, so we have our general idea already written down. Now we can start on the individual problems. Okay, say for problem A, the limit of f of x as x approaches 1. Okay, so how do we start on that one? Well, we find out where 1 is. Okay, so since this is 2, our 1, let's say it will be somewhere over here. So let's say this is our 1 right here. Okay, so since our 1 is over here, which is less than 2, our f of x, why did I put 2x plus 2? I meant 2x plus 3. Glad I saw that. 2x plus 3. There we go. Okay, so it's less than 2, so our f of x is 2x plus 3. So that means this just becomes the limit of 2x plus 3 as x approaches 1. It would be the same thing if you had x approaches 0 or x approaches negative 1 or any value at all to the left of 2. Okay, so how do we find the limit? Of course, the very first thing you try is direct substitution. So we just plug it in. Okay, so 2 times 1 plus 3, which is equal to 5. Okay, so we know that our limit as x approaches 1 is 5. We don't have to graph the 2x plus 3. This is strictly as a guide to help us. Okay, so now we're going to work on problem B. Okay, which is showing that you have x approaching 2 from the left and right. So since we're approaching 2, we have to take that into consideration. Okay, so since the limit of f of x as x approaches 2 has 2 different functions, we have to test both. Okay. Now the thing is, when you were approaching 1, 1 is less than 2, or x equals 1 is less than 2. So we only had to deal with that one function right up top when we approach 1 for A. But for B, since we're approaching 2, you have 2 different functions as you approach 2. So approaching 2 from the left is a completely different function than approaching it from the right. Okay? But to solve it is exactly the same as A. You just find out the limit from both directions. Okay, so we try to keep that showing as much as possible. So from the left, as we approach 2, the limit of f of x as x approaches 2 from the left. Okay, we're going to start using that terminology. You want to get used to it. Okay, when you're approaching 2 from the left, your f of x is 2x plus 3. So that's equal to the limit of 2x plus 3 as x approaches 2 from the left. Okay, now since you're just approaching 2, of course, the very first thing you do is direct substitution. That's just the easiest. So you go ahead and plug in 2. Okay, it's not negative 2. Don't mistake that for negative 2. That's why it's on the right side of the value. That's just 2 from the left. So you're just going to plug in 2. Okay, so you have the limit of, not the limit because we're plugging it in. So we're just having 2 times 2 plus 3, which is 7. 4 plus 3 is 7. Okay, so we know approaching 2 from the left, that limit is 7. Now we find out how we approach 2 from the right. Okay, so you have from the right, you have the limit of f of x as x approaches 2 from the right. Okay, so when you're approaching 2 from the right, you're approaching 2 this way, so your f of x is x squared plus 1. That's equal to the limit of x squared plus 1 as x approaches 2 from the right. And again, first thing you want to do is direct substitution. Just plug that sucker right on in. Okay, so 2, replace x, so you have 2 squared plus 1, so you have 4 plus 1, which is 5. Okay, so we see here that when you're approaching your limit from the left, you get 7. When you're approaching 2 from the right, you get 5. They aren't the same. So whenever they're not the same, you know the limit doesn't exist. Okay, so since the limits are not the same on both sides, of 2, it does not exist. Okay, so that means the limit f of x as x approaches 2 equal does not exist. Alright, so that's how you would approach a piecewise limit. Alright, so hopefully this made sense, and I'll see you on the next video.